Today we are going to talk about the concept of domain. As most of you know, domain is all possible x values. So often when we begin discussing functions, we want to know about the domain of functions. So what we're looking for are all the possible x values that will work within the given equation. Now what we have to remember is that if we consider all possible x values, we're talking about negative infinity to positive infinity. And well, that's a lot of numbers. So sometimes we want to think about what x is not allowed to be as opposed to trying to go through every possible number and figuring out what will work. And so as you enter into a pre-calculus setting, and even in the beginning of calculus, you only have a few things that you have to worry about. This is what the way I refer to it is, what are we worried about? And when I say what are we worried about, I mean what are the areas where if we have certain numbers in certain places it causes a problem. And so as we go back through all of our mathematics and we begin to think about where it was that when we put a certain number in a certain place we kind of got in trouble, then those are the things that we have to worry about. One of those things is when we have a 0 in the denominator. This is what I refer to as bad math. We can't do this. So we're worried about that. So if we have a function that has an x in the denominator, where there is a chance that we are going to accidentally divide by 0, we need to look for what values for x would cause that so we can eliminate those from the domain. Another thing we're worried about in these early stages of mathematics is we are worried about a negative underneath the square root. Now a negative underneath the square root gives us an imaginary number, but when we're dealing with functions we're mostly dealing with real numbers. So this is another bad math thing. And honestly, at this point, until you get a little bit further into working with some other functions like trig functions and logs, etc., these are the only two things that we're worried about. So when we're looking at a function, we want to ask ourselves, what are we worried about? And from there, we can help build what needs to be eliminated from the domain. So let's say we had the function 3 over x minus 2. So I'll go back to our, what are we worried about? Well, what we're worried about in this case is getting a 0 in the denominator. We don't want that to happen. So the best way to prevent that from happening is to find out what would make it happen and exclude that number. So we're going to take the denominator and set it equal to 0. And when we do that, we find out that x is equal to 2 causes us to have bad math, and we don't want that. So we're going to exclude that from our domain. So depending on the way your teacher professor wants you to write this, you might just be able to simply write it as all real numbers where x is not equal to 2. But if you're asked to find the interval notation, which in most cases you're going to head in that direction, you're going to have a positive 2 that is not included in the solution, but everything else is. So if you put it on a number line, you can kind of get a feel for how vast the domain is. And if you want to write interval notation, keep in mind that interval notation tells us the smallest value for a given interval and the largest value for a given interval. So if you graph this on a number line, you can see how many intervals you're going to have. You've got an interval that represents this, and you have an interval that represents this. So we're going to have two intervals we're going to have to name. The first interval has a smallest value way out here, and that is negative infinity. And we always put a parenthesis on our infinities. And so the ending of our interval is going to be at 2. But because we have an open circle of 2, because we're trying to eliminate 2 from the interval, we are going to put a parenthesis on that. Now keep in mind that using interval notation, the parentheses is for a less than or a greater than, so it does not include that number. and the bracket includes the number. It's a less than or equal to or greater than or equal to. The way I remember it is, I think of this bracket as being like a barn door that's getting slammed on the number and it's locking the number in, but the number kind of escapes from a parentheses. So in addition to that interval, we're going to join that with another interval that picks up on the other side of 2. So it also doesn't include 2, but it starts just on the other side of 2, and it goes all the way to infinity. So this is our domain for f of x. So let's take a look at another problem. What if we had the function g of x is equal to the square root of x minus 7? Now, keeping in mind that we said we absolutely do not want to have a negative underneath the square root. So if we're not going to have a negative underneath the square root, what are we allowed to have? Well, what we're allowed to have is a positive number or 0. So that x minus 7 must be greater than or equal to 0. And this is going to give us our domain. If we solve this for x, we get x is greater than or equal to 7. And if you're allowed to write it in this format, we could say that it's all real numbers where x is greater than or equal to 7. But if you're asked to write it in interval notation, once again, if you're just learning interval notation or you struggle with it, I would recommend that you graph it. Because it includes 7, we have a closed circle there, and it's shaded for all the values greater than 7. And then when we go to think about our interval notation, we can think back about how many intervals we're going to have. Well, in this case, we only have one interval, and it's right here. The smallest number for that interval is 7. And it includes the 7, so we need to lock it in with that barn door, and it goes to infinity. So this is the domain for g of x. Let's take a look at one more. Let's say we had the function h of x is equal to 3x to the 4th minus 4x squared minus 7x plus 6. So I'm going to go back to our original question. What are we worried about? And going back and looking at the things we were worried about zeros in the denominator and negatives underneath square roots. So with h, what are we worried about? Well, there are no x's in the denominators of fractions, so we don't have to worry about getting a 0 in the denominator. And there are no x's underneath square roots, so we don't have to worry about getting a negative underneath the square root. So we're not worried about anything. And oh my gosh, that is a great feeling to not be worried. We're not worried. If we're not worried, that means that we do not have to restrict our domain. So that means we can plug in any number we want to into this function and it will be defined. So that's from negative infinity to positive infinity. Thank you for watching this video. If you have enjoyed this video, please give me a like, subscribe to my channel. If you would like for me to make a video especially for you, add a comment in the comment section on a topic you'd like for me to make a video on, and I'll do that for you. I look forward to having you watch further videos.